Little Kids by Professor Alex.
This is the lesson for little kids by Professor Alex.
Okay. About chemistry.
About chemistry. This is the first lesson.
Okay.
This is about matter.
Oh, okay. Let's have a look.
What is chemistry? Have you ever wondered what the world and the objects in the world are made of? What is water exactly? Why do ice cubes float? What are our hair and skin made of? Why is a marble hard by a jellyfish soft? All of these questions and others like them begin the inquiry into the branch of science called chemistry. Chemistry is the study of matter, which is a general term for what forms living and non-living things. Chemistry is concerned mainly with the properties of matter. All of that we encounter on a daily basis are made of matter. Balloons are made of matter, pancakes are made of matter, but baseballs are made of matter. Even our bodies are made of matter. But what makes up matter? The fundamental building blocks of matter are atoms. The word atom comes from the Greek word atomos, which means uncuttable. During the 5th century BC, the Greek philosophers proposed the idea there must be some most uncuttable units of matter. They call these units atoms. Today we know that atoms are composed of smaller particles called protons, neutrons and electrons. Protons and neutrons are roughly equal, and so the electrons are very much smaller than both the neutrons. Protons, neutrons and electrons are all much smaller than an atom. Protons and neutrons combine to form the central core of nucleus of the atom. The electrons occupy the space surrounding the nucleus. This space is sometimes called the electron cloud. The number of electrons in an atom always equals the number of protons. Notice that for the helium atom there are 2 protons and 2 electrons. Sometimes the number of protons also equals the number of neutrons, but this is not always true. Most of the space of an atom is actually filled by the electron cloud. The central core of an atom is only a very small part of the total space. On the other hand, almost all of the mass of the atom is in the protons and neutrons and nucleus. The electrons weigh almost nothing compared to the nucleus, but yet they take up all the space. All the atoms that make up the world are known. They're called chemical elements or just elements. Early in the 19th century, a total of 55 chemical elements were known. Many more were being discovered. The properties were very different from each other and it was difficult to organize them. In 1867, Dmitry Mendeleev organized the elements into what's now called the periodic table of elements. In today's periodic table, the elements are arranged horizontally from left to right in the order of increasing atomic number. The atomic number of protons which is in the nucleus of each atom. For example, carbon has an atomic number of 6, which means there's 6 protons in nucleus.
Oxygen
has a wide atomic number of 8, which means there's 8 protons in the nucleus. All the elements have a symbol. For example, hydrogen has the symbol H and carbon has the symbol C. Notice for the symbol is the same as the first letter of the name. It's true for me, and it's because I'm names like alpha. Some come from the name for sodium from the Latin languages.
And then that comes with natrium.
Natrium has the symbol Na. Tungsten comes from the German word Wolfram, so it has the symbol W. Examples include gold, which has for AU from the Latin
and lead.
The atomic number tells how many protons the atom contains. In an atom, the number of protons equals the number of electrons. So this number is also the number of electrons in an atom. For example, the smallest element is hydrogen. It has an atomic number of 1, which means it has only one proton. It also has only one electron. The number of protons equals the number of electrons. Though atoms are very small, each one has a weight called the atomic weight. For most atoms, the atomic weight is very close to the sum of the protons and neutrons in the nucleus. Both protons and neutrons have an atomic weight of 1. Electrons are so small that they are given almost no weight at all. The number of neutrons for an atom can be calculated by subtracting the number of protons from the atomic weight. For example, the atomic weight for hydrogen is 1.0079, which is the number found below the 9. So to find the number of neutrons, the number of protons 1 is subtracted by the atomic weight 1.007779, or 1 minus, so 1 0.
So no protons.
This means hydrogen has no neutron and only one proton in its nucleus. The largest natural current element is uranium. Uranium has an atomic number of 92 protons and 92 electrons. It has an atomic weight of 238.0289. To calculate the number of neutrons, the number of protons subtract from the atomic weight 238.90
minus 92.
146. The uranium is 146 neutrons.
That's a lot.
Virtually, the elements are arranged according to the chemical properties. All of the elements have a strange column.
In a single.
All
the elements in a single column.
In the single column undergo similar chemical reactions and have similar chemical properties. All of the elements on the far right column of the periodic table are called the noble gases. They are similar to each other because they don't react with other atoms or molecules.
The elements on the
far left-hand column are called the alkali metals.
The alkaline metals?
Alkaline metals. They are similar to each other because they react with lots of different atoms and molecules. The periodic table of elements organizes a lot of information about the elements and their chemical properties. This table helps chemists predict
the behaviour.
Predict the behaviour of the elements, how they might interact with each other. Therefore, all of the
naturally
occurring elements will know when the level of atoms predict many properties of the missing element organization. We know
the success of his predictions.
Organization of his chart led to overhaul and
acceptance
as a major scientific accomplishment.
Very good.
Here are the most important points to remember from this chapter. All things, both living and non-living, are made of atoms. Atoms are made of protons, neutrons, and electrons. In an atom, the number of protons equals the number of electrons. All atoms, all elements, are found in the periodic table of elements. The elements are arranged on the periodic table in groups that are similar.
Now, Alex, can you tell people how old you are?
5.
And when was your birthday?
12th of January.
And what's the date today?
I don't know.
You sure?
I don't know.
What month is it?
February.
In what year?
2010.
And do you know the date?
No.
28th.
28th.
Yeah. Good boy.
And you love chemistry?
Yes, and I love chemistry.
Thank you for reading that chapter.
Yes, and now reading chapter 2 tomorrow.